Hello friends, welcome back to my channel. So how do you solve this integral? I am going to solve this integral using the beta function. So let's walk through it. So let's start off by first doing a u sub. You can let u to be equal to the third root of x, which is equal to x to the 1/3. Then we differentiate du dx is going to be 1/3 x to the negative 2/3. So that implies that du is going to be 1/3 x to the negative 2/3 dx. So we can isolate the x. So dx is going to be 3 du all over x to the negative 2/3, or 3x raised to the power 2 over 3 du. So if u is equal to x to the 1/3, then x to the 2/3 is going to be u squared, right? So we can write our dx in terms of u as 3u squared du, like this. So in place of dx in our integral, we can replace that with 3u squared du. And the limits will stay the same, because when x is equals to 0, u is going to be 0, and when x is equals to 1, u is going to be 1. So really, we can now take our integral from the x world into the u world. So that will be the integral from 0 to 1 of the square root of 1 minus this is u. So that is u times dx. What is dx? dx is 3u squared du. So that is the integral from 0 to 1 of 3u squared 1 minus u raised to the power 1/2 du, because the square root is the same as to the power 1/2. So 3 is a constant, can go in front. The integral from 0 to 1 of u squared times 1 minus u raised to the power 1/2 du. And then I am now going to compare this to the beta function. I'm going to compare this to the beta function. So if we have the beta function of m and n, I've been doing this. This is the integral from 0 to 1 of x to the m minus 1, 1 minus x to the n minus 1 dx. And our integral really looks like the beta function, because this one can also be written as 3. The integral from 0 to 1 of u to the 3 minus 1, 1 minus u to the that is going to be what minus 1 will give you 1/2. That is going to be 3 over 2 minus 1, like this du. So our integral is going to be the beta of 3 and 3 over 2. And we can use the gamma representation of the beta function. So if we have beta of m and n, this is the same as gamma m, gamma n divided by gamma of the sum m plus n. So this is what we can do to solve our integral. So our integral, which is really this one now, which is 3 times the beta of so this is 3 times the beta of 3 and 3 over 2. Using the gamma representation now, is going to be gamma of 3 times gamma of 3 over 2 divided by gamma of the sum, which is 3 plus 3 over 2, right? And that is going to be 3 times gamma of 3 over 2, and then gamma of the sum, that is going to be 9 over 2. So we are going to utilize this. We know that gamma of m, a lot of properties that we have to know. Gamma of m is the same as m minus 1 factorial. And in the same time, we also have to use this identity. Gamma of m plus 1 is the same as m gamma m. So we are going to utilize these two identities of the gamma function in order to solve this, our integral. So our integral has now been reduced to this. So this is 3 times gamma of 3, that is going to be 3 minus 1 factorial, which is 2 factorial, times gamma of 3 over 2, but I'm going to leave that one as it is. Gamma of 9 over 2 can also be written as gamma of 7 over 2 plus 1, right? So this is what we have. And I'm going to have 3 times 2 times gamma of 3 over 2 all over. This is now 7 over 2 gamma 7 over 2. That is using this identity. And 7 over 2 can also be written as 5 over 2 plus 1. So that is going to be 3 times 2 is 6 times gamma of 3 over 2 all over 7 over 2, and then gamma of 5 over 2 plus 1, because 7 over 2 can be written as 5 over 2 plus 1, which is 6 times gamma of 3 over 2 divided by 7 over 2 times 5 over 2 gamma 5 over 2, and that is what, which is 6 times gamma of 3 over 2 divided by 7 over 2 times 5 over 2 times gamma of 5 over 2 can be written as 3 over 2 plus 1. And using that identity again, we are going to have what? 7 over 2 times 5 over 2 times 3 over 2 gamma 3 over 2. And we can see that gamma of 3 over 2 cancel gamma of 3 over 2. And that is going to be left with what? 6 all over 7 times 5 times 3 all over 2 times 2 times 2, that is 8. And that is going to be 6 times 8 all over 7 times 5 times 3. So that is really what equal to, if you work that one out, that is going to give you 16 over 35. So that is be the value of our integral. So if we integrate from 0 to 1 of the square root of 1 minus the third root of x dx, this one evaluates to 16 over 35. That is using the beta function and the gamma representation of the beta function. So that is how we solve it. We utilize the gamma representation of the beta function and these identities in order to solve the integral. So if you really find this helpful, please subscribe to my channel, smash the subscribe button for more engaging tutorial from Calculus Diaries. I thank you so much for watching this video, and I will catch you up in the next one. Bye bye.